We are continuing our derivation of equations to solve for acceleration, velocity, time, and displacement. And this is going to be equation number 4. This one also is going to be called position as a function of time. As function of time. But this is for where we don't have any final velocity. No final velocity. We don't know that, so we're given other items to punch in. Well, again, so like we did before, we're going to have to remember some previous equations to put in. If you recall number 1, our first derived equation, number 1, was that final velocity equals the initial velocity plus acceleration times the change in time. Oops, that's number 1. And number 2, the very next one that was finding average velocity, the average is the same thing as 1/2 VI plus VF, our initial velocity plus our final velocity. These have to be established because this will enable us also, like the last one, to make substitutions in here. So average velocity, V average, you'll also remember is a change in position or change in displacement over the change in time. So we're going to put, we'll put this in for average velocity. So our delta x over delta t equals this from above, right here. I hope I didn't get that in the way. I probably made that arrow a little bit too long. There we go. Equals 1/2 times VI plus V. Oops, I didn't really draw that very well, did I? VI plus VF and we're also going to substitute in our number 1 equation. So our VF from up here is going to go right in there. So all this is going to substitute in for VF down here at the bottom. So let's rewrite this once again. Our delta x over delta t equals 1/2 times VI plus all this above, plus another VI plus A times delta t. That is our VF from above. So what we can do to simplify this is we can take our delta t that's on the bottom right here, and we can multiply both sides by delta t and bring it up, and we'll put that in the numerator right here on the right side of the equation. So to simplify this a little bit yet further, we have delta x equals 1/2 delta t times everything in the parentheses. We can combine these two VI's right here, can't we, into 2 VI plus A times delta t. But even further, we can take this 1/2 delta t on the outside and we can distribute it to all items inside the brackets right here. So I'm going to take this this fancy pink pen, and we're going to move up to the top right here so we have a little bit more room to work. So we're going to distribute that 1/2 delta t to everything on the inside. So our equation turns out to be delta x equals, well, if we distribute the 1/2 delta t to the 2 VI, the halves and the 2 is going to cancel out. So it's really going to become VI times delta t plus, now we're going to distribute the 1/2 delta t, so it's going to become 1/2 times a, and since we've got 2 delta t's there, it's going to become delta t squared. Delta t squared. And this is going to be our final equation right here. We don't have a final velocity, we have initial velocity. We have elapsed time, acceleration, and we have our displacement. And we can solve then for any one of those variables in here without having to have our final velocity.